Let's continue with section G and generate random points within the 4 different unique land cover types that we created using the combine command. So in combine we created this layer that shows a unique combination of aspect and habitat class. And in this step we'll create random points because the task is to create sampling locations within each one of these unique combinations. So we're going to open up our toolbox, go to the data management tools, go to File, Feature Class, and then create random points. And the output location, you can specify whichever folder you want to put it in. I'm going to keep working in my C temp folder. And give a name to the output data set. That's going to be my random points. Constraint feature is going to be my herd boundary because I want all the points to be within the herd boundary. And let's say that I want to create 100 random points, and I might want to specify a minimum distance. And of course here you could use some spatial statistics tool to see how autocorrelated your data layer is, but we haven't really looked into that yet. So I'm just going to say that they need to be 100 meters apart, but this should really be tested to get a distance that is statistically justifiable, so to speak. So let's go ahead and say OK there. So we now have a data layer called random points. I'll open the attribute table, and there really isn't very much in there. We got our 100 points, but they basically have no information associated with them. And if we were to actually go to these points, a couple of things we would like to know: the x and y coordinate, or lat long if we're working in that coordinate system. In this case we're working in UTM coordinates, so we're going to look for the easting and the northing. And the second thing we would like to know is which of these unique combinations of slope, or no, not slope, but aspect and habitat type they're in. I'm going to give them a different color here so we can see the points. So there they are. I mean, you could go to each one of the points and look at what type they're in, but that would take an incredibly long time. So we're going to use a different tool in our toolbox, in the spatial analysis tools, and extract the value of the raster to the attribute table of the point layer. So in spatial analysis tools extraction, extract value to points, you can do that. So my point feature is my random points. My raster is this combined layer of aspect and habitat. And my output's going to be called random combined, maybe. Combined. So we're going to add those combined values. And that's probably going to go pretty quick. And let's open, oh, it actually created a new layer. So I'm going to click off the old point layer and look at this new layer. And look at that. So now in the attribute table we can see for each point you actually have which raster value it is located in. So the next thing we want to know, if we're actually going to go to these points, is the x and y coordinate. And you can calculate that in ArcGIS. If we keep our table open here, and we need to add a new field. I'm going to call that x for the x coordinate. I'm going to make it a float so it has decimals with it. And let's Make that a little bigger. I might as well add my y coordinate as well. Make that a float. And then you can calculate the value. So just go ahead and say calculate geometry. And I want to, my x coordinate of the point, and I'm going to use the coordinate system that I'm using for all my data. I'm using the UTM Universal Transverse Mercator System Zone 11. And in this case, it's pretty old data, so it's in the datum NAD 27. Most new data is in NAD 83. Units are meters, so that should work. And there are my coordinates. Same for the y. I'm going to go for the y coordinate. Go ahead and say OK. And there you go. So now you can grab this file. You could export it, I guess, first. You would need to export it as a text file. And then you could import that table to your GPS unit.